it's natural. Basically, what happened, naturally through the history. And then she went through the Karamba analysis of this giri in hands-on grasshopper. And hopefully today we will cover the second cluster of this workshop, which is bio intelligence in architecture, basically biointelligence. And the first thing that we want to talk today is, sorry, I'm so sorry, but sometimes seems that we need to mute participants. So yeah. The first part I will talk about I will share my screen. It's better to talk in this screen.
Yeah, now we are on air. Okay. And you can go on. Have a good lecture,
nice.
Selda.
Thank you. Yeah, it's actually very on time. Can you see my screen properly? Okay. Zoom has some problems. Okay, because of that, I will go very fast and close this. So maybe it can be easier. Yeah. Okay, yeah. So for today's workshop, we're covering okay, sorry, it seems that sometimes when I'm sharing my screen, this is happening, but I think it is just sometimes. Let's try one more time. Okay, do you have my screen now? Okay. So the second cluster is nature-based design, which we have to, and we will talk about how nature can help us in our design research work. So today's agenda is actually, for my presentation side, is that to first go for a very quick introduction to nature-based design, and then the nature in computational design, which I will cover some of my own computational works. And then we will have a quick review of biointelligence data flow, and then we'll go to Physarum in more detail. The most of the time is for Physarum because it's the most important one to talk. By the way, all the visualization that you can see is by Eric's last name, and you can see all the references in the background also. Okay, introduction to nature-based design. So as you know, when we talk about nature, we immediately can imagine some geometry and some mathematical relationship between these geometries. So I would say this nature, geometry, and mathematics has quite interesting and very complex relationship with each other, and they can help us together to understand the nature, geometry, and mathematics, and to solve complex geometries with the help of math, which comes from nature. And there are many I would say approaches and levels to inspired by nature and use nature as our tool maybe. For example, let's say as an example, I will just move this. Hopefully you cannot see this. This is just very simple example of paper wasp nest, and this wasp usually make their own nest in such a interesting way, and it is very how to say, it's very informative for us to see how they are collaborating with each other to create this complex geometry and with different materials. So they usually use their saliva mixed with different wood and wood material from different resources, And because of that, you can see that the texture of the the nest is quite different in colors and shapes and forms. So just as an example, this is one simple phenomena from nature, but we can see many different inspiration from it, and we can extract this for our design research work. Like, for example, let's say the cover of the nest, which is the paper wax, we can use it as a recyclable and sustainable material. And we can see that, okay, in our architecture, it can be a waterproof material or thermal isolation. Another inspiration can be with its interior design for the circulation of what is happening inside, for our natural ventilation, for our temperature control and accessibility. Then we have form of this nest. So this nest actually, because it is based on nature, so nature has this ability to form the most optimum shape according to the conditions that it desires, demands. So we can use the shape of this for sustainable structure, for form finding in our structures, especially for temporary small scale structures. Another, again, approach is to use this order of how they are basically installing these modules to our 3D printing ideas. The process of 3D printing in industry, which can be prefabricated. Recently, actually, there is a study between UCL and University of Pennsylvania, I believe, regarding this 3D printing based on nature. So, but okay, we understand that, okay, there are many approaches in biointegrated design, but all in all, let's categorize this approach to two main approaches, which is one is a bottom up, which is biology push. So in a bottom up biology push, what we have is that we have a phenomena, which is our, the case study that we have from nature. And then we are studying its functions, its methodology, and its anatomy, and whatever is in as a natural rules, basically, inside that phenomena. And then by understanding the principles of that phenomena, we can abstract that and extract this information to our own design research works. So after that, we can implement these ideas, which came from nature, to our technical, basically, keywords that we have in our own field, like industry design. It is in architecture. It is in many other engineer fields. And then we have the final output as a bionic product. On the other hand, we have top-down approach. So what is happening in top-down is that first we have a problem. We have a problem and we want to solve this, but we want to solve this inspiring by nature. So what we do is to search in nature to find, to figure out what we have in nature, and if nature was in our place, how nature would solve this problem for us. So after that, we are funding some case study based on nature, which is means that we are basically going from like a technology pool. We have this mindset that we need a solution for this problem. And then after abstracting and extracting this information from nature, again, we are testing and we are implementing it in our own design process. And then we are reaching to bionic product. I hope that my speed is good. I'm not going too fast, but all in all, this is two main approach in bio integrated design. If we want to see it in another form, this is again bottom up, as you saw here in the bottom up. This is the same thing, but showing how it basically goes, the different process. Basically, we have the identification of the that natural phenomena, and then we are translating it to the our to our own problem, and then we are discovering how we can basically interact with this phenomena according to our own problem. And then we are after abstracting basically means that after changing these natural rules to our own design rules, you know, some tools that we can use it, some solutions that are they are logical and accessible in our own field, then we are emulating it in our design. And then after that, the main thing is to evaluate all this process to understand if it is according to what we wanted, you know, our original idea, and if it is really according to our natural, you know, according to natural process which could happen. So we are evaluating our design based on what could happen in nature to understand if our process was, you know, reasonable and logical or not. Okay, I would say let's go jump to some case studies, because I think by seeing some case studies, maybe you can have a better understanding of bio, because biodesign, biodesign is a very, you know, the wide range of information and resources are available. But for our workshop, I wanted to cover 3 main case studies, which are, I could say that they are quite similar to our approach in Ardana or in this workshop. So the first case study is a tree structure canopy, which is by Asteris Agatidis. Sorry, pronunciation of Greek names. But you can find his books and research papers, which are amazing, you know, according to nature, how they are using in their Liverpool University and, you know, with his team. This is just one example, and they wanted to design a canopy for entrance of a hotel, I believe, and they inspired by the anatomy of a tree, but not just in the form, but also according to how a tree can carry loads with, you know, through its branches to the ground. So as you can see, they started with some grid tessellation, and then go through all the computational process to reach a point which they can say that, okay, these elements are optimum enough to carry you know, to make this system entirely. And as you can see here, this is the which, you know, in the under construction, and this is the cover of it. And then they studied all the joints and, you know, the basically the finite elements analysis, and they reached to this prefabricated elements. I have to skip very fast, but you can find quite good resources accordingly, you know, with this resources, with these references. Another one is the research pavilion 2014-15, inspired by water spider, which is this guy. And as you know, ICD and ITKE have the very good fascinating actually case studies regarding bio-inspired design and research, and this is just one of them. And here I choose this case study because what is happening here is the agent-based behavior that they studied to understand how we can have this analysis according to structure and energy, and how we can reach to the point which we can have the optimum process of 3D printing wherever it is really necessary to have it. So it's like a study based on agent based, but inspired by nature. I need to go very fast. So this is another one which is my favorite. Silk Pavilion by Meditated Matter Research Group in MIT Media Lab, directed by Neri Axman. And what they studied here is that they studied the behavior of silkworm, and they understood that according to the environment, this worm can knit, the environment and shape that cover, for its silk cover, and they understood that okay, we can also cover and make this space according to the optimum phase of the nature, how nature basically can act in our design. So what they did is actually they made this frame for the silkworm, and the worms started to knit all around this this temporary structure. And I really suggest that you can watch Neri Axman's TED Talk also regarding this project, because it's really fascinating how she explains that almost all the silkworms here were all safe, and it's like a new approach to use nature according to our because of according to our desires, but also not eliminating them. So she was explaining that none of the silkworms killed by this research, because the way that they are using is just to use them for this silk, but not like what is happening in silk industry, by boiling them after creating this cover. So it is quite interesting how we can have this balance between nature and our technology. And yeah, I hope that we can have more of these researches. Okay, this was very quick, introduction to nature-inspired design. And in this part, I will cover just very quickly some of my own projects regarding computational design and biodigital. So this is one of the very my favorite quote from two scientists. One of them is a biologist, and one of them is data scientist. The development of an organism may be considered as the execution of a developmental program present in the fertilized egg. A central task of developmental biology is to discover the underlying algorithm from the course of development. So one of the case studies that I want to talk about here is, this is my dissertation in 2020, and it's an intersection between space frame structures and also bone tissue. So I was searching for inspiration for a phenomena from nature to give me a good optimized structure, because as we know, bone tissue usually repairs itself all during our life. It never stops, almost never stops growing and repairing. And I wanted to have this self-organized structure based on user interaction with the structure. So it was something like between biology, like bone tissue, and also a pattern from our existing space frame. And I used, so here you can see the keywords usually, which I used Voronoi to mimic the structure of this structure to this to shelter. And here you can see the tools that I usually I used for this. And I used biomorpher also here because one thing interesting about biomorpher is that it can give us generations and the best the best solution, but not just like selecting according to nature and structural analysis, but also it can cover designers' mindset also. So yeah, I will move to the next one. I know that it is very quick. Continuing the previous study, this one was in my master's degree. So here so that the previous work, I faced some problems like the interconnection between these Voronoi cells. And here what I did is to use Python this time, you know, the coding in Python to solve these two problems. How can we apply a random geometry to a preferable freeform surface as a parametric system? And how can we reduce the chance of overlapping points in the hub networks? So one problem that I faced in the previous one was that these overlapping points caused some, you know, if it goes to some kind of, let's say, 3D fabrication, we might have some problems with overlapping of points. And this can happen because this can be a problem because of the cost and energy, you know, because when we don't want to have the very, how to say, overqualified, basically over structure. So what I did is, again, to use the mathematics to solve this problem. And as you can see, it was quite successful. I cannot say it was 100% successful, but as you can see in many different freeforms, this is my original freeform, by the way. In many different freeforms, it was quite, acceptable. Sorry. Another project is Silk Pavilion. Actually, this one is inspired by Silk Pavilion of Neri Axman, and because I really like how you know, her perspective regarding the nature. But it was just form mimicking, basically. It was not that much, you know, huge research behind it. But I wanted to see how can I reach to this random but basically logical, how to say this, wrapping around the building. So my inspiration was this kind of spaces, which is by RDAI group called Hermes Reeve Coach. I hope that I'm not misspelling too much. And also the Silk Pavilion itself. So I started very simple with some curves, just very, you know, from my architectural background, nothing else. And then by choosing some random points and selecting closest points of that random closest point of the surface, I could reach to that points which I wanted. And then I could create the cross section by, you know, this VRAP to covering that space. And again, bone tissue, like usual, I'm so fascinated by this phenomenon. They are here, you can see a few furnitures, basically just designed by bone tissue. This shows actually the three different methodology to reach to the almost same, you know, like Voronoi kind of texture, which I wanted to see how which one can work better, you know, flexible. And I realized that this one, the first one, actually had a better output because it was quite flexible just by giving one curve, attractor curve. I could have a more flexible structure at the end, and also I could change the surrounding cube of it, you know, bounding blocks. So that one also was a quite interesting flexibility. Another was coral circulation, which inspired by sea coral. And here again, I went through the computational, very simple, to be honest, very simple, because, you know, they are just like a practice to understand the biological, basically, you know, the computational logic behind these biological forms. And then after reaching to this point, I again inspired by another work of Asteris Agatis, and it was like this L system fractal tree structures, which combined, which could give us these cubes, parametric cubes. And according to that, the result was like circulation among the, like, let's say in residential place or whatever, to, to reach to that optimum circulation of a building. Brain coral shelter was another practice, just, an exercise, which was mostly with kangaroo. And here it was just a very usual freeform surface, and then the projection of this line on that surface, and then this brain, brain kind of pattern was creating, growing gradually all around the surface to reach to the final shelter, the cover. And this is a bit different approach. Here, there was no algorithmic design actually, but what happened here is that this guy here called Mimosa, actually the very short form of the name is Mimosa, although it has very difficult scientific name. So what happens here when by it can expand its leaves and then again close them by touching. So I was thinking that how we can basically use this in our design just for a very quick, the city shelter. And in this form, it was like when it was open, it could be like a branch for people to sit. And then when it was closed, each branch, it could be like a shelter for people to just stand under that. So yeah, as you can see, it was very quick overview of, just to give you some idea how simple really they can be, an inspiration from nature. Just, I didn't show you the fabrication part, the fabrication projects or, machine learning projects combined with biology, biointegrated design, because of the workshop time. But yeah, also you can, you can expand this your research and your design, how much you want and how much you can actually. The third part of the project, I'm not sure how much time I have, but yeah, this is the very short part. Biointelligence data flow for performative attributes. So here I want to actually discuss our previous workshop with Mahdi and Pourali from Ardana. This is workshop Learning X, Bio-Inspired Design and Machine Learning, which was Digital Futures 2022. And I was a student in this workshop. So what I learned here was such a interesting field, interesting perspective, because they actually combined this bio design, this bio intelligence plus data from machine learning, how to basically apply machine learning to this bio data. And what happened there was that we started with in grasshopper environments, and we produced some alternatives, like I believe thousands of alternatives from L system bio, from this our bio case was L systems. I will show you later. And we generated this L system formulas based on Karamba analysis, and then we converted this data which we had to Jupyter Notebook, and we converted it to a meaningful data for us, to cluster this data for us according to the displacement and other structural basically factors that was important for us. And then again we went through the grasshopper environments again, to use this clustered and this time, labeled data. Basically, I should say clustered, not labeled, clustered data to our work, and again optimize that specific formula which we reach to that according to our design. So I will go a bit further. So, and I hope that you can understand better. So this is what happens in L system. So L system is like a subcategory of fractals, and they can go. They have a specific formula to move forward or turn to right or left, and this has its own mathematical. It's like a language for itself. And they had this Python code for this to generate this data for us, with different formula from nature. Then we had this structural analysis on them according to our preferred freeform structure, freeform surface. Then by clustering this data according to, here you can see displacement, elastic energy, and the weight of this element, we could cluster them. So first, there was no kind of, the data was not understandable, but with the help of machine learning, we could understand the data. So we choose basically, I believe, this category because it was the best result, basically the less, the optimum between different factors. So basically in this stage, after Jupyter Notebook, again, we went through the grasshopper and some selected formula like this, as you can see here. This is one formula from L system. Based on this, we had around 300 elite, basically the genes which were selected as the best candidates for our machine learning, from our machine learning to our Karamba analysis. And then Karamba analysis, as you can see, with different formula, 300 formula, it gave us the different solutions, and the best solutions was definitely the optimized of this formula and the other structural factors, and also like something like the angle between these branches or the height of the structure, and whatever we really wanted to consider. And this was one of the latest, basically the end results. This was me and Ariana, my teammates, poster. As you can see here, we defined the site for ourselves, imaginary site, and then we defined this thousands of case studies, basically thousands of alternatives. And then this was the meaningless, for us actually, meaningless data, and then we changed it to be meaningful in clustering. And this was the selector, sorry. Yeah, it is obvious actually. This was the selected formulas. And then again, by going again to Karamba analysis and by Galapagos, we choose the best option, which was this, according to our design. Okay, I'm so happy that we covered 3 parts, and now I will give I will pause here, and I want to see if there is any question before continuing to Physarum. And I hope that I was in time. What do you think, Ahmed? I was on time or not?
Yeah, I think it's okay. And if we have, I think 5 minutes or 10 minutes for Q&A, then we can go to the next phase, and then we have a break. Yeah, I think it's okay. Everything is okay and on time. Yeah, guys, if you have any question, you can ask Selda now about these projects and these approaches that she has explained.
Notice 45 minutes. Okay, yeah, we are on time almost.
Yeah. Yeah, okay. I think if there isn't any question, we can go to the next part, Selda.
Okay, yeah. Then we can again return to questions anytime.
Yeah, just pay attention because Mustafa Islam, he has a question. Please ask your question, Mustafa. Unmute yourself and ask your question. Mustafa, do you hear me? Can you quickly explain?
Yes.
Selda can.
Yeah, why not? So I will share my screen again. Do you have my screen? Okay. So the machine learning part was this part. Okay. And what we did here, I just hope that it won't cut my screen. Sorry. So what we did here was so after oh no, sorry about that. Yeah. Sorry guys, this just happens when I start sharing for some reason. Okay. So what we did for machine learning is that after the Karamba stage, which was the generating some alternatives like this much, basically thousands of alternatives, we recorded this data in an Excel file. So this Excel file had many features like the label of this, basically the index of these formulas, the formulas themselves. Then it has displacement, weight, all the structural factors that we wanted to basically, consider in our design. And then after that, this Excel file, we opened it, in our Jupyter notebook. And then in our Jupyter notebook, we used k-means to cluster this data for us. So what k-means does, I cannot see my mouse, very strange. Why I can't see my mouse? Okay, yeah. So what k-means does is that it's kind of a clustering method in machine learning, and it basically categorizes our data to some meaningful data for us. And we can understand by, for example, by colors or by by labeling the cluster. For example, here, as you can see, they are 5 labels. So basically, we have 5 clusters here. By labeling them, we can see the data, how the distribution of data is and we can choose from one group, that elite group, which we want that group, we need that group because that group has less weight and less displacement, which we need that, and it has less elastic energy also. And then after that, we collected just that data. So in Jupyter Notebook, there are these different levels, and you can easily go through them, in Plotly and NumPy, different many libraries that you can extract the data. And we extracted that elite, which was around 300, I believe. And then by this 300 data, which again was an Excel file. No, it was not Excel file. Actually, we just imported them as a, you can just import it as a text file, CSV file, whatever you want. We imported that again to Karamba. So that Karamba worked with Galapagos to give us the optimum result for all structural phases and also our architectural aspects, like, the height of the building and all these different factors. I hope that it was clear, but yeah, I wish actually I don't have the Jupyter notebook right now, But yeah, I wish to go through that also.
Yeah, totally. It was, I think, obvious. And thank you for your answer. If any other question about the projects, about the explanation that Selda has for machine learning. Also, we will have a lecture by Mahdi on machine learning, and stay tuned for last day that we have Mahdi on board for machine learning, an amazing machine learning lecture. Okay, another
Sure.
question if you have.
Yeah, I think I will just start with Physarum, because that will take time, to be honest. And yeah, so what I will do, okay, so this session is about Physarum, and what we have some pattern formation explanation mechanism, and also modeling. So for pattern formation, we want to see is the narrow.
Yeah, I think we have the same problem. Let us some minutes to have Selda back. I think, yeah, she has the same problem.
Hello. I'm really sorry.
Again.
I don't know why this is happening every time starting. I think, I just need to, without pausing, I will just continue.
Yeah, do not stop. Yeah, do not stop your screen share.
And I will wait a bit because it makes me very distracted. It shows lots of notification.
Yes, we have your screen, and I hope everything will be okay.
Yeah, it's just the starting. I don't know, maybe it's because of my graphic, hopefully. Okay. So is the neural system the only way to be intelligent? This is our question here for Physarum, actually. And okay, let's start with Physarum itself. So Physarum is a single-celled organism known as a type of slime mold. It shows different behaviors throughout its life stage, and the plasmodium stage is the most studied phase of its life because of its fascinating function as a kind of intelligence, which differs from what we know as the definition of intelligence. Can you hear the sound of this video? No, you cannot hear the sound of video. Okay. So then I need to skip this maybe. Or let's see if I can. What about now? You don't have any voice, yeah? What about now? Okay, you have it.
Slime mold. It's a sort of
I'm sorry, but we can't hear the voiceover in that video.
I think giving the YouTube link could help us to watch by ourselves because it's from the YouTube. So YouTube
You
link
couldn't.
could,
Oh, you didn't hear
no,
the.
we couldn't hear. Yes.
Yeah, at the first second we have the
Thank you,
voices of
Mustafa.
Aziza.
Pardon, what happened?
Yeah,
You didn't hear it entirely?
Yes.
Okay. No worries at all. Actually, I will skip this. Anyway, we have the entire explanation. But I wanted to show this because it was interesting to, to hear it from the researcher themselves. But let's see let's go for the mechanism. And here we want to see how does a single cell give rise to a complex structure. So maybe you remember this game from your childhood, or maybe right now. This mechanism works like an agent-based behavior. So the agent-based behavior approach is inspired by chemistry and math models. It works well for systems where small interactions lead to huge emergent behaviors. Guys, by the way, all the resources you can find, and I will also mention them gradually. So you can go and check the resources, the researchers themselves. Physarum is a special kind of organism with a jelly-like body that contains nuclei surrounded by a membrane. Inside this jelly, there are fluid and fiber-like structures. It can naturally change its thickness, creating a back and forth fluid movement internally. This allows it to sense changes in its surroundings and move towards areas with more nutrients. When it finds food, it forms pathways to transport the nutrients all over its body. By the way, I will give this part of presentation so you can go through the keywords properly, and if you need any further info for studying on your own project. So foraging efficiency depends on two main factors: covering the largest possible area and also minimizing travel distance. So as you can see in this GIF, it shows that it is skipping this long path to reach with the shortest path possible. Physarum can balance these two requirements through growth, movements, and area reduction mechanisms. When presented with a choice between two passes, it efficiently finds the shortest route. This unique capability allows Physarum to navigate mazes, create efficient road-like structures, and solve various pathfinding challenges. So in modeling, we want to see how to use this intelligence in our functional paradigm. As a base model, so based on Professor Jeff Jonas's research works in University of West England in Bristol, this model uses cell migration and a synthetic chemical approach. It's similar to ant colony optimization, but differs in how agents move. Like in ant colony optimization, simplifies the environment into a graph, while this model allows agents to physically move on a semi-continuous grid, overcoming the limitations of discrete movement and connectivity. So let's go very quickly to understand the keywords of this phenomenon, so that we can use it in our work, like in modeling and simulation. So the simulation takes place in a 2D world with two regions representing the environment. Particles in the simulation represent individual Physarum organisms, and they move based on the levels of pheromone tails around them. Each particle possesses a heading angle, which indicates its movement direction, and three sensors for detecting pheromone concentrations in front, to the left, and to the right. The particle's sensor readings determine the pheromone concentrations at the three spots around it, which influence its rotation direction. The particle may rotate straight ahead if the pheromone concentration in front is the strongest, or randomly choose a direction if concentrations to the left or right are greater than the forward concentration. If the pheromone concentration is greatest on the right, the particle turns right, and if it's greatest on the left, the particle turns left. After determining the rotation, the particles move forward in their new heading direction. Each particle leaves a pheromone deposit on the current world after moving forward. Pheromones are then diffused to neighboring spots, spreading out their concentrations using a Buller routine. And finally, pheromone decay subtracts a small amount from all pheromone values, representing the pheromones evaporating or drying out over time. So this process repeats and the particles continue to sense, move, deposit pheromones, spread out pheromones, and undergo decay in subsequent simulation steps as long as possible and necessary. So by the way, this visualization here is by Sage Jensen, which you can see here, and I suggest to go through his resources, which is really good, information gathered together. So for data map and trail map, so which you can see here, is that the Jones model consists of two layers, the data map and the trail map. The data map is agent-based and consists of multiple particles, while the trail map is continuum-based and represents as a 2D grid with intensities similar to pixel-based image. The interaction between these two maps are reciprocal. So in the data map, this layer comprises numerous particles, each represents an agent. These particles can move around in and interact with their environment. On the other hand, trail map is represented as a 2D grid with intensities at different locations. And these intensities can be thought of as a trail left behind by the movement of particles from the data map. So the interaction between these two, what is happening is that the particles in the data map interact with the trail map in two ways. First is through contribution to the trail map, which is, as particles move across the data map, they leave behind trails on the trail map, and the intensity of the trails at a given location on the trail map increases based on the number of particles passing through that location. And on the other hand, gathering information from the trail map again happens in this interaction. The particles in the data map also use the information from the trail map to influence their movement decisions. They may be attracted to areas with higher trail intensities or repel from areas with lower intensities, affecting their trajectories. So about the diffusion and decay, so these keywords are important because we're gonna cover them in the grasshopper file, and we'll use them to optimize our Physarum performance. The diffusion operator can be described as a pseudo parallel simple mean filter in a 3-in-3 kernel. The purpose of this diffusion operator is to model the speed of chemoattractant. This chemoattractant is a chemical substance that influences the movement of particles or agents in the system. The decay value determines the extent of chemoattractant persistence. A higher, let me show you this. So a higher decay value means that the chemoattractant diffuses and loses its strength more rapidly, while a lower decay value allows it to persist for longer period. I hope that I'm not going very fast, but don't worry at all. Just just listen to some keywords, and then we can to practice them in Grasshopper. So sensor distance and rotation angle. In the simulation, every particle possesses essential characteristics, including a heading angle, a spatial location, and 3 sensors: front left, front, and front right. These sensors play a significant role in determining the particle's behavior, influencing its heading by either causing it to left or turn right, or maintain its current orientation. And this is a summary of what we discussed. You will have this power, so you can check the keywords whenever it is necessary. So it has lots of use cases when how to use Physarum. For example, in tech and industry, like controlling robots and their movements, path planning, construct logic gates and machines, graphs and optimization, and so on. This was also another. We don't need any voice. Just I wanted to show that how actually we can also use Physarum as a creativity for our art. This is by again by Sage Johnson, I believe. But anyway, the resources here, and to just I need to do this, reduce the time. And as you can see, over time, according to the angles and all the factors we talked about, that artboard can change to be something completely abstract. And we recently have had a research paper on biodata flow and force flow integration, which was based on Physarum by Mahdi, Patrice, Crispina, Ahmed, and me. And yeah, that also will be available very soon, hopefully. And yeah, this basically this work that we are doing in this workshop also is partially of the further step of this research, which in this research was according to the machine learning and form finding, and here we will have as a optimization. So yeah, you can see also the references later. And yeah, that's it for today. Thank you.
Thank you, Selda. Please do not just, oh, you have stopped your
Why?
screen share. It's okay.
Oh, you wanted to, I think we need to go for a break, and then after that, maybe
Yeah,
you
I
want
think
to share the grasshopper.
you are very on time, and we have finished on time. We can have Q&A and your questions, but before it, we have a question that Juliana, I think, asked. She asked that, do you know if there are bibliographic references that show the geometric pattern through microscopic observation on the nanometric scale of Physarum?
Okay, for Physarum, I'm not sure, to be honest, but I have some resources for that scale of the studies in that scale, and which I can share. One resources which usually is very handy and very accessible is Ask Nature website, which it's very handy and it's very inspiring very quickly. But if you want something deeply, I need to find the resources and I can share with them. But I'm not sure about the Physarum.
Yeah, thank you. Guys, if you have any other question, you can ask. After that, we will have a break, and then we will jump into the grasshopper. Yeah, guys, there is no question. Mustafa, I think you can ask a question because you the guy that you have some question always. Yeah, I'm joking. Yeah, it's okay. If you don't have any question, we can go for a break for 15 minutes. We'll get back on, I think it's gonna be 5 p.m., yeah? 5 p.m. of GMT, yeah?
Yes, exactly.
Yeah.
Yeah, okay. So
Yeah.
see you guys in 15 minutes.
See you soon. Hello, everyone. We are back, and yeah, okay. I think we can start.
Yes, sure.
But yeah, but I think we can wait a minute if anyone in trouble to connect, and then we can start. Now we will start with some examples from how Physarum act in Grasshopper, and then we will jump into the workflow, and I will explain what the workflow are doing, and then we can have your questions, and at last we have your projects. Okay, Selda, if you are ready, you can start.
Yeah, I think I will start sharing my screen because it will take a couple of seconds to figure out what to do. But first of all, I wanted to mention the Nuclei plugin itself. If you go to Food for Rhino and search for Nuclei, you can easily find and download it. So Nuclei is by Madeleine Georg. I hope that I'm spelling properly. And here you can find the version, the latest version, and also some example files. I also uploaded the same example files to Google Drive if someone has some difficulty with the downloading, but they are actually the same files, so we are gonna talk on them. I will close this just to have a better connection. Okay, so for the first example, I will just gonna show quickly 2 examples. And the first one is intro. You already have the files in Google Drive, or you can just download them in Food for Rhino. And let me check this here. Okay. So first to start it, actually, this is the simplest way to to create a Physarum environment, and we have our 2D environment as we talked, like that data map and trail map, and then we have our space. Basically, this is what we are defining our voxels inside this, and we are giving this voxel to this. Okay, let me put this. So this is our basically voxels to construct that voxel environment for Physarum to move around, and we have the solver, the Nuclei solver, and what it needs to basically to run this algorithm through Physarum idea concept is to have voxels, particles, and settings. So voxels is this environment, and then we have the particles. And for particles here, as a very simple example, we give just a very the random points as our agents. So these particles actually will work as our agents, like the Physarum particles. And then we will give this to Physarum solver, and then we will have some settings as we discussed previously, like the sensor distance, rotation angle, sensor angle, trail size, and diffuse, decay. This important ones. So let's go just very quickly and run this so you can see it better. So now our particles are ready to move. And I think this perspective is not that much bad, actually. Okay. And as you can see, the iterations are happening here. And gradually, according to what we decide, as our, the setting of the parameters, they are moving. And for example, if let's change this to 6, if you want to see what is happening. So you can see that the speed is a bit too much, that it creates like a jitter, you cannot understand what is happening, and the particles don't have time to understand the workflow, the environment. And then distance, sensor distance, how we can, the particles can understand the distance to go through that. Sensor angle, rotation angle. Again, you can play with them to see what is happening. But it is mostly about your own, design work. You will see what works better for your design. As you can see, some islands, because of the angle, is 90 degrees. Some islands created. And then again, after a while, this again, finds its sustainability. Okay, let's go to the next one. It's just very introduction level. So just to to feel what is happening, the environment. Again, we will need this. Again, we have the voxels here, and then this time, which is this guy. This time, instead of having 2D environment, we have 3D environment, and we also want to limit its movements, the Physarum movements. So why we choose this example? Because we will have this almost same behavior in our own work. You need to limit your the voxels to be in that position. For example, let's say we are limiting it in this sphere, and we are giving this point as attractor point. So it will be the first point, the first emergence point. So it will start from growing from that side. And we will give this point to the attractor point, to define our starting point position, the particles position, the start position. And again, there are other settings, but they depend on what you want to achieve. You don't need to use all of them, but definitely you will have, for example, the trail setting and the particle setting. Okay, let's go and run this also. Let's see if it will work. Okay, yeah. So this is our starting point. We don't need this. And as you can see, it will go. Yeah, it started to the iteration from that point, but gradually it will find their way to be surrounded by this sphere. So this needs to be entire sphere like this. But yeah, I think you got the idea at least. And Ahmed will continue, deeper in details for our own project. So but it's all, just test and error to see which parameters will work for your own work best. I will just stop here. Without stop sharing, do you guys have any questions? Just in in this part. If not, we can continue to our own project, and you can see different parameters there. And then after that, we can have then all the questions together.
Okay, so I think if there is any question, we can answer it now. And then if there are any, yeah, just as a side note, we have some other plugins to do so, and it can simulate the growth pattern of Physarum. But Nuclei is one of them that I think it's better alternative for what we're gonna do in this workshop and in this research. I think, yeah, I will go through the workflow, and you can see that there is a lot of things that we can do with Nuclei. Thank you, Selda. Take a rest and be ready for the question and the participants project.
Yes, sure. Thank you.
Okay. I will share my screen. You can find these files in the Google Drive. So you need to install Nuclei Dendro for this. Just as a question, do you see the grasshopper window?
Yes, we see.
Yeah, I think because I think the Google map have some problems with Rhino and grasshopper together. But yeah, here I wanna go through it. Just let me a minute. Box space. You can remember that these kind of outputs from what Behnaz has done in the Karamba and the Gure pattern. Sorry, I think. Do you have my voice clear, or is okay? Because I've seen some unstable internet connection. If there is any problem, please let me know. Kind of this output from the workflow from the first cluster that we have based on Gure and some structural analysis from Karamba. And then you can see that it is the base freeform surface. And I think maybe you remember that we have another guidance surface for defining a workspace. I will go through all of them. Just let me hide both of them. Now you can see if we use some environmental and some lines as a wall, you can see that what is the output. And if we use, for example, the force flow, that if you remember, Behnaz have some explanation about the region number 2, the index 2, that it was the region that we have some elements in pressure or some compression, and we have some elements on tensile or different force flow. I will go through script, just please promise me to that you you can follow me but one step by step, because you're gonna work with this workflow, and you should have some output from this workflow. Okay, we have some base surface. As I said, it should be a bit upper, but I will explain that you can change something. In this scenario that I have, a bit upper to, I have this surface a bit upper just to have the Physarum and the output of the Physarum have some intersections with my base or my Gura output. For example, you can see here that we have some intersections and we have some connection between these two. But for example, if we use the same surface, we cannot see this intersection, and it's one of the reasons. Yeah, I will go through it. For defining work cells, or for defining a workspace for Physarum, we need two main things: some attractors and define a workspace. Initially, I will go through making some work cells. You can see that we have here some work cells, or I can show it here. Here. Yeah. For example, you can see all of these box, these bounding box. I have a bounding box here for the surface that I have. Then I have this workspace to make to define initial workers for workspace. As I said, we have two phases. Initially, I will go through how we should create our workspace. You can see that we have here this output. That is our final workspace, that the Physarum has the permit just go through these work cells, and do not have the permit, for example, to go through these spaces that I have subtracted from the main surface. To do so, what I have is to create a surface here. You can see that. For example, I have some surface here that is on the ground. It's my second surface that I have, and then a rule surface, and then I will join all of them to have this surface. Yeah, it's a bit more near to what I want. Then I will do some solid difference, or subtract some spaces, some boxes from that. I will just describe that these boxes that we have it here. These are just for defining, how can I say, define a workspace, or define the spaces that we want. I was thinking that we can have some algorithmic approach here to create some spaces, but now I prefer that give you some boxes just to subtract from your main workspace. Because, for example, I want how can I? For example, we have an entrance here. We can define a, for example, define a box here, and we have a line here that it's gonna be our wall. For example, you can see that Physarum doesn't go to these boxes, because it's defined that it is not your workspace, and it is because that we subtract these boxes. Yeah, for example, if you want, you can change all of them. For example, if I want change these boxes or change any scenario, for example, we can move it. And then an event, for example, or change anything from these boxes. These boxes just define your, how can I say, define your spaces that you want. I will go through it better, but these boxes is what's define your spaces here. Just because I internalize them, I can choose them again. I should deselect this. Okay, we have all of them with all of the changes here. Then create a mesh. That is the mesh that define our voxel. And what this Nuclei component does is every voxels that we have here, if this mesh include that voxel, it will give us that. You can see that it's voxel inclusion in mesh. I think it's very clear. Okay. The simultaneous or parallel line, we have the, how can I say, the attractors that we have. For example, we have here some of them from the force flow. Yeah, from the force flow and the scripts that Behnaz has explained to you. And we have some environmental, that is very simple ladybug script that gives us some points with most based on sun direction. And we have some base points here on the corners of the how can I say, the corners of this freeform structure. The highest proportion is indicated to these base points because we need some base points and in the detailed design, and to have a more rational output, we should have some base points or some points to define and can define based on force flow, defined on environmental, to how can I say, to act like a cladding to the main structure, to have some connection there. Okay, I have two lines here. As you can remember, I can go to the top. Yeah, these lines are like walls, and this wall, I can go through this line and change it as I want. If I want to change, for example, if I put it here, maybe because it's near to the base points, we have some connection there, and maybe we have some closed space there or closed wall there. These lines as a wall, we can define it here, and I have some points here just to define my walls. And yeah, before defining these voxels, I should create some voxels here, just to how can I say, just it's based on the mesh that I have here, to have some voxels that I choose these voxels or these attractors from these attractors, just to have two main filtering the data and filtering the voxel. Because maybe if I use the same one I will have a lot of voxels as an attractor. I can filter it just by a step here, and then go to the next level. We have some. I forgot something here that it's about the voxel size. I have something parametric here to create your voxels. Just keep in mind that these voxels for this case, just to do not your laptop do not crash. Make it always between, I think, 150,000 to 200,000 voxel is enough for this case. Okay, then I will please pay attention more in these components. I can define different attractors for what we have here, the points that we have here as an attractors, how we can define them to the Physarum as an attractor. You can see that what's happened here. I don't know what's happened. We have these points. I can keep these environmental. Yeah. For example, we can see some base points, some points for the environmental analysis, and some points for wall. I think you can remember that maybe we have some connection there. Keep it in your mind. But we can make or define some attractors based on curves, based on points. But what I prefer there, that define all of the voxels by the number of the points, not just about for example, the maximum range or minimum. This maximum and minimum range is, for example, if we have something here, it's defined for us that in which range or in which scale these voxels can grasp or can absorb some other particles to us. Is some and it is, for example, here as a 1 centimeter. So, for example, just an example, we can you can enable this component and, for example, give these curves to this component. But what it will be happen? You can see that these lines will absorb a lot of our Physarum that maybe it's gonna forget that what food we have here for the environment, for the environmental analysis that we have. Just to have a better proportion, I use this. Maybe in your scenario, we have some cases that you can choose a tractor, but I disable them in this case, and even I have some other points. If you want to, for example, you have some points that you think that's more important, more important than the others, you can define a voxel separately. Okay, then all of these voxels gonna be our foods here, and the multiplier is again something that's multiply its energy, or its how can I say, grasp all of the particles to itself. Yeah, then we have here a union between these works we have here, and we have these points here, or these voxels as a food. We have a union here, and on the other hand, we need some setting for our nuclei. I think be aware that these settings that you have it here are selected very accurately, and I think maybe you can change this sensor distance and you have another or unsuitable output. I have the speed here on 0.2, and sensor distance. It was Selda explained to you that what sensor distance do. It's exactly, for example, if I have a particle, for example, here, this particle just will go to 0.6. I think, how can I say, the distance, just if there is any food in less than 6, it will go for it. But if there isn't, it's gonna do another thing. And you can see that sensor angle that we have here, that you know about it, Selda explained it very well for you. And the rotation angle that I give this we have two kind of angle here. One of them is for the sensor, and one of them the rotation. For example, the sensor angle, for example, is 60, and the rotation angle is something that it can rotate itself, not for or sensing something. It's for its moving, not for the angle of the sensor. And the deposit that we have here, that's how the trail will be how can I say, will accumulated in that points of the foods. And we have the trail size that I think it was clear from Selda's presentation, and the diffuse rate and the decay rate for the delicacy that we have here and the accuracy we need. I think this range is going to be enough, and even it's these numbers is I think it's resulted from a lot of iterations that I do for different settings to reach this point. Okay, after that I'll define all of this and hide this backspaces. Yeah, I can. Okay, I can run it, run the solver, and yeah, I can wait to what Physarum gonna do in this case. I think we can see from the top. Yeah. Here. Okay, let it when we will reach to iteration number 100, I will pause it. Okay, I think it's gonna be enough. You can see that's what happened here. For example, we have a wall here. And as I mentioned before, I said that maybe we have some connection between these two base points with this wall. Or you can see that it's, yeah, with this.
So usually how many iterations it's better to go through till?
I think after 50 iterations, you have something suitable. But just for being sure, I think I just noted that I think 250 is going to be enough for that, for your final project, not for even when you are testing anything. I think 50 if it's gonna be enough. And you can see that we have some points here that how Physarum go for all of them to cover all of them. And you can see, for example, here, for example, we have these points here as a wall, and it's gonna go for all of them, these base points. After these iterations that we have it from these, yeah, it's got, we have different, how can I say, different way to shade or presenting what we have from Physarum, but it's one of them that I think it's very clear for what we are doing. And after I've done anything, I have here something from Dendro that I give all of the points here, I give some smoothness, and then we have a mesh here. Yeah, we can change the setting for it. For example, the point radius, I'm gonna change it. Preview. Yeah, I think when we have some huge points, I think it's gonna be okay. Iterations. Hey, this iteration help us for to have some more smooth mesh. You can see that what it's doing for us. And then we will transfer it to some mesh here. Then we can bake it or do with it anything that we want. Just keep in mind that you can define different attractor points for it, and for example, even we can change the number of points here, or change the maximum range that voxels can attract, or and other things that you can have it here. We can define some value for every voxel. These voxels I make it as a food because the different things that we have here, for example, and maybe sometimes we have some points or some voxels that we want to define some value for example, sensor distance or speed. But when we put it on the food, when we have some union with it, it's gonna be, for example, this union that we have here. It's gonna work well, and when we have the union for the workspace, it knows that this value, this voxel that we have from here, is gonna be our food, and this gonna be the workspace that we have here. And another thing that I want just to mention is the same process that Selda has in the examples, that we should have some random points for the particles, because even in the nature, we have the Physarum as a random points that go through the foods, go to finding food, and accumulated everywhere that they find foods. Yeah, that's it. I have nothing to add. Please, Selda, if I forgot anything to mention, please add it, and then we have the guys.
It was great. Thank you so much. I would just suggest to go through all the workflow, just to tell the main parts, you know. Okay, see, guys, we have this color categories by Behnaz, which is amazing because you can understand which color basically it works with which approach, with, for example, it is rhino, it is the Greek pattern, or it is Karamba, or it is Physarum, whatever. So you can see here that all in all, we have data from Karamba, data from environmental analysis, and then this all goes through to be a food for Physarum. But Ahmed, if you can just quickly, just in a very big picture, just to show what we did, the entire workflow in as a very glimpse to what is
just
happening.
for the Physarum part, or for all of the parts?
I would say right now I think now it is the time to just review all of them, very quickly. Yeah, just say that, okay, this is Giri, and the export of this, basically the output of this went to be import for this category, and so something like that.
Yeah, thank you. I think it's gonna help us with review what we have done until this moment. Just to remember what Mahdi has in his lecture, that he was saying that that it's our approach, that the Gura as a geometry that can do some structure for us, or it can cover the structural functions that we need. Simultaneously, we have some how can I say, some research objectives or some architectural functions that we need. This it comes from Physarum, that is have more flexibility, and it's gonna work in a more free and with a less rigid kind of attributes. Just go for it. We have some Gura here. I think I will go through it very quickly. Yeah, we have some different Gura that Behnaz has created for us. It's gonna be different Gura that we have, that we can apply it on our surfaces that we have, based on what Karamba gives us as a force flow. Yeah, and then for example, in the modules that we have more force flow and more accumulated tension, there we have the Gura more closed, and when we have and with a more closed, and to do better function as a structural elements, and simultaneously we have some parameters that and some regions. I can remember. Yeah, I think, yeah, these points. This comes from the Karamba based on the region that we have here. Yeah, here. For example, region number 2 that I have mentioned before, that it gives us different range of the force flow that we have here. For example, if we have an issue in every region or in every force flow that we need to, how can I say, empower, and we have some, for example, change the cross section or everything that we think the Physarum can help us with it. We can change the region from there to find the critical points in the free form. And one of the critical points in free forms, it's where we have both of them, the compression and the tensor. And then we have some other foods that, just in this case, keep in your mind that you are not have to just for example work with environmental analysis. If you have any other things to find to define for the Physarum as a food, for example, you have some architectural aspects or some I'm not really sure about it. For example, this is a sun direction, and for example, the some sun radiation that we have here. For example, you're gonna do something for shadowing or daylight analysis or any other different data flows that we can find for Physarum. And then we go through Physarum that we have. You have you should define a new surface or for it. Just you can, for example, make another surface. Maybe some of you think that this freeform gonna be in another one, not just moving it a little bit. Just maybe it's you think that for your functions, for the function that you have in your mind, another surface is gonna do better, or it's in your case it's gonna be very in your case. Then we have the Physarum to defining its attractors and define a workspace just in the two simultaneous or parallel lines. And then yeah, that's it. So after the setting of Physarum based on what we need, we can turn on the solver, and then we can change it or translate the points to a mesh. Yeah, that's it. It's just all of the things. Just in one point, Physarum is something act as a cladding or something attached to our base freeform that is from Graph. Yeah, then I think this sentence can define anything that you want. If you have something structural and you think that you should solve it in structural phase, go for the Gura and go for the what's Karambad does. And if you have some architectural things to do or define something architectural, or for example, defining some spaces, defining some shadowing, some cladding, all of these things gonna be the role of Physarum. Sorry for my long sentences and my long lecture.
Thank you, Ahmed. Yes, hopefully now you have a bit of overall understanding of what is happening. But this is just one scenario that you can go for it. We are open to see creative ideas, how you want to implement these two layers of Giri and Physarum in your work and add an additional aspect for it. So here we just used a very simple ladybug for some radiation on top of the surface. But yeah, this is your choice to see what is your concern and what is your research focus. For example, maybe someone goes for acoustic analysis, to understand, okay, which part of this surface needs more covering, to have this balance between the acoustic levels. Or someone wants to focus on structure again. And this time Physarum can work as, to act like the structure, structural, an element to cover the structure, to help this structure to be flexible, stable. Another point is about architectural aspects. Again, you can implement architectural aspects by using that box, barrier boxes, which Ahmed explained. So you can have a wall inside your shelter, that space that you want to design, as a designer. But also you're using Physarum intelligence to help you to cover that place, to give you, this understanding that without trying to, to push a design element inside your architecture building, how you can just define the space that experience that the users want to have, and just let the Physarum do the rest of the thing. So it will be like something like based on natural intelligence, that we are talking about, this interaction between a designer and basically nature. So yeah, there are many different scenarios that you can go, and this was our approach. One of the workflow, the methodology that we wanted to to complete it from 0 to 100, and then we will continue to develop it into other stages, like to implement machine learning in its as a library of different Giri patterns to understand which Giri pattern really works properly with this workflow, or other kind of natural patterns, like the library of patterns in nature, and which one can be more helpful according to our architectural and structural or energy analysis, whatever is in our mind as our research approach. So it's quite wide kind of opportunity to explore it, and we hope to see your work using this sample, but also adding your own concerns as a designer. So yeah, what about any questions, guys?
We are waiting for your questions. Is there any? It means that you do not have any question.
Did you could you open the files, maybe at least the example files, or I believe that example files couldn't be any problem with them, but if try to open the main file which Ahmed actually uploaded in Google Drive for second cluster in second cluster folder, I believe. And for tomorrow, we can go through that to see if you could manage to see what is happening, to run the algorithm, and maybe come with some idea about the your point, your site, what you want to focus on it, or how you want to have your own approach according to this workflow. And we are also very happy to have some critics actually for our workflow, because we are in development stage, and we want to see how we can have a better, logical, reasonable workflow for our next research, research work, basically the next step. And here again, I want to say thank you to for this platform. Now that we are live for the first time, let's say thank you to Digital Futures and Argano team. And I also mentioned that I included all the resources about Physarum and whatever was about biology. All the resources are there, and you can have access to them. I also uploaded the PowerPoints there. The PowerPoint was quite heavy, so I uploaded the PDF, but if you want, I can upload the PowerPoint also. So it seems that we have a Mersad says that I just got one small issue, which was not functional, but visual. Okay, during reviewing yesterday's tutorial. Yes, sure, yeah. And yeah, also you can share it here, or if you don't mind, even you can share your screen. Yeah, just feel free, because now we have half an hour, and it will be nice to to see what is in your mind, or what is any kind of issue that you have, so that we can move to the next year, not next year, next day, to review the entire process together.
Okay, if you do not have any question, we can go for your project. Oh, Mirsad, I think you have something to say, yeah? Yeah,
Yes.
please.
Hello, everyone, and thank you for
Oh,
all the
Mirsad.
wonderful and amazing information, spending so much time and effort during this workshop. I don't know, maybe I can share it here. Is it possible to share image here, or
Do you want to share your
Uh,
screen, or is it just you prefer to have a?
yes, maybe I can share my screen?
I think we need to change it. Yeah. Or Ahmed, can we change?
Yeah, now you are
Okay.
a co-host. You can share your screen.
One more. Okay.
No problem.
Can I share now?
Yeah, share your screen.
Mhm. Can you see my screen now?
Yes, we have.
Functional one, you know, as I just I was reviewing the videos, and I noticed that the lines here, the vertical lines, were like interpolate lines with like degree 3 curves, but mine were like polylines, something like that. I wanted to ask that in Discord, but thought maybe same thing could happen to others. Is it something that related to
Mirzad,
doing?
we have some issues to hearing your voice. Please turn off your camera. Just turn off your camera. I think it's going to be better.
Is it better now?
Yeah, I think now.
Can you?
Go on. I think it's
Okay.
going to be a bit
I
better.
was just wondering that if this is like polyline shapes, these curves, is there any like problematic situation, or can it be fixed like the one you did yesterday, which was like interpolate?
Hi again. No, ours was the same also. I don't think that something that's matter with this, algorithm, but ours was like this. Oh, I think it's because of the points on the points. When we are extracting the force flowing crumble, we give it a series of points, right? I think that's that is what is causing this. Maybe the number of the points are different. The number of the points coming from when we turn the surface into the mesh. If you remember in the starting of the algorithm, we have a series of number. Maybe that's it. But I will work on it, and hopefully tomorrow we're gonna have Mahdi, and we can ask him to make sure if I'm right about this or not. But as far as I know, I remember mine was also like yours, a series of lines instead of some um, soft curvature. But also, I love your design. This is marvelous. Thank you for practicing and taking your time. Thank you.
Thank you so much. No, I know it doesn't look any functional problem. I was just curious to know that what's the difference between the thing that I did and you did, because shapes are like breaking points and polylines, and yours were like very smooth curves with degree 3 interpolated. And that was just this. I thought just maybe same thing happened to others during the redoing the forms, and I can mute my microphone. Thank you for the time. Thank you again for everything.
Thank you.
Mirza, just I want to ask you something. Please, if you have any scenario for that, it is, what do you think about it? This form what's gonna be covered in your scenario? For example, the environment, the climate that you gonna use it. If you have any further explanation for it, you or other teammates that you have, I don't know your teammates now. If you have anything to explain, I think it's gonna be something to help the others. Okay, I think the other guys, if you have any other problem or any other points to ask, we have a question from Juliana. Sure, do we have
Okay, hello, Selda ma'am. Hello, ma'am.
Hello, Sajad. We can
Yeah,
hear your voice. Yeah.
Hello.
I sent you a message to Selda ma'am. I don't know. I'm not sure if she aware of it or if ma'am will see the message, because I'm not very used to with the Discord system. So if ma'am could see my text and give me a feedback on it, then it could be helpful. Because
Did you send it in Discord?
yes, I sent you a message.
Okay.
Please,
Yeah, and right now I don't have it open. I need to open it. But is it fine if you just send it here in chat so I can?
it's a group
Everyone.
of message. I mean, group of picture.
Okay.
I think I
Okay.
have to share
Okay, no problem. If you can, you can also, if you want, you can also share your screen. But if not, I will try my best to yeah, answer it very
It's
quickly.
in my another monitor right now because I am with the laptop, but it's okay. Just guide me over there. It's okay. Just replay me there. It will be fine.
Yes, sure.
Whenever
No
you
worries.
visit.
No worries at all. Yes, sure.
Okay, thank you.
Okay, so can you answer the question from Juliana?
Yeah, I'm answering. Sorry. Yeah, I will write it down. Yeah, I will write it down.
Thank you for that.
So we can continue with any other questions are there?
Yeah, guys, if you have any other question or problem, and if you have not, you can, everyone from any group can share your idea and what is the idea you have for the forum, and what do you think with the barriers and hindrance that you may gonna face because of the workflow. Yeah, share your idea with us.
So Juliana was asking about, in short, do we have to create a bio-inspired structure with the Grasshopper code you gave us, or a completely new code? So let me just explain it to others also. So this is our suggestion for this workshop, because we found that the Physarum has this opportunity, make this easier for us to give our this sensitive weak points, like from environmental, from structural, from architecture, as a food for it. So we found it interesting to use it, like what I mentioned, as a bottom up, that kind of approach. But you are also free to use your own algorithm, whatever you have. If maybe you are using Voronoi, I don't know, you're using brain coral structures, you can, with kangaroo, with other kind of relaxation, whatever you think that, okay, it can help for your own design, combined with our Giri structure, that can also help. This is just an example. It's like, that there are many solutions to solve maybe a problem, and we are testing. We are also in test and error phase of this research. So this is one of the solutions that we reach to it. And for the next step we will try to actually implement it in our own Python code, so it can be, you know, more specific for our own project, and it can be, you know, how to say it, basically specific for our design and research needs. So yeah, just feel free to use whatever you want.
Just a side note, this workflow is an initial point for our research, that if you think that all of you, if you think that you can contribute to this research, is an open project to develop it more to the next stage, where we have something in our mind for the next steps of this research and this workflow. It's really based on the output that we will have, that your outputs will give us the idea, and it's always our approach to holding workshops, to find the talents, find the people that can contribute to our team, contribute to the research projects that they have, or even is defined from our side. There is no difference. It's just an opportunity to learn more and know you, and you know us better, to go for the next level. So if you have any other new idea, please feel free to ask it, that maybe you have something that we have never thought about, but it's okay.
Yeah, exactly. It's like, you know, the workshops are the best opportunity to have this interaction and share ideas, and, you know, to just learn together, basically.
Okay, I want to go through the groups, and I will call some people, some participants from the groups, and just want to share their idea, that's what they are thinking about, even maybe some initial points, everyone's conceptual phase in your mind, just, but it can be a good start point for us. The first group, I think, Faiza, Mariam Hassan, Defna, Mudra, Mahmoud Reza. I think we have Mudra here, we have Mariam here, and Faiza from this group. Yeah, all of you can go for more detail on what you are thinking about your projects, and even it's a good opportunity to your teammates to know about your idea. Okay, Mudra, I think you unmute yourself for 1 second. You can say what.
I have an issue with the camera, so I won't be able to start the video.
It's okay. It's okay.
Can you hear me? Oh, yeah.
Yeah, very clear.
So yes, actually, we had a power outage yesterday, so I was reviewing yesterday's video today evening. So it's actually midnight here right now. So I'm still working on the Giri patterns. So I attended the entire session today. So I'll be continuing with that tomorrow. But yeah, so the question that I had asked on the first day on the group chat was to, will this process help me to analyze the growth and decay patterns of biosynthetic structures? So something on similar lines is what I was thinking, like the silk pavilion that Neri Oxman had designed, or the Eguahoya structure by Neri Oxman. So it's like, what if we use biosynthetic materials and trace their patterns of growth and decay, so that we can see how ecological the structures are in terms of performance. So again, this is my third time in the Digital Futures workshop. So the first workshop that I attended was by Professor Mark Burry, where he took the workshop called Analects of Gaudi. And we designed kinetic facades based on biomimicry. And concepts, the hyperbolic parabola concept by Gaudi. So this has come from there that, how do you make structures more ecological, a part of nature, not just inspired by nature, but a part of nature and performative in its way. So think about something on similar lines.
Thank you. Yeah, it will be amazing. Thank you so much. And don't worry about the teams. We understand, and we will have a time, quite a bit of time to figure out. For now, just try you. I think since till this session, you could observe good amounts of information, and know that you have this overall idea of what is happening in our workflow. Maybe for tomorrow you can have come with some concepts, at least about the focus of your research, which part you want to focus on it for your design research work, and then we can discuss it. You can discuss it in your teams, and gradually fill the Miro board with your ideas. So yeah, I think till today we are not expecting to have maybe something to present. I mean, to talk about even the ideas. But maybe for tomorrow, gradually we are in a stage that gradually we can insert to the ideas, to some sketches, to some images, whatever. Maybe you can share your own previous work, your research work, your design work, your portfolio about what is related to this workflow, and you can share the ideas, so we can also learn about them, and then you can implement or go further in your design path or in your research path accordingly in our workshop.
Thank you so much.
Thank you.
Yeah, if you have any other idea, you can share it on the brainstorming box that we have on Miro board. Okay, we can count it on your behalf of your team, Mudra. The next team, I think we have Hamid Reza, Omnia, Saktiwal, Branko, and George. Any of you guys, if you have any idea to share, Branko, Maria, no, Omnia. We do not have Omnia now.
Ahmed, you remind me like the school when teachers used to ask questions or
it's just a discussion. No, it's just a discussion.
Suddenly very
no, take it easy. If like what Mudra were discussing, just about her idea, it's okay. Anything you.
Could you please give me the permission to share screen? Then I want to share
Yeah.
idea. But I'm not sure, so I think I should. It's not organized, but I want to share.
Yeah, I can give you the permission now. Yes, Azad, now you can share your screen.
Okay, thank you.
You're welcome.
The share the screen. Okay. Is it visible clearly?
Yeah, it's right.
Okay, this is one of my current project. I actually shared this with my groupmate brother, the big brother. So I think I should share with you because I don't know that it will be workable for further studies or not. Wait, let me find. Sorry. Okay, here is something. I actually sent a clear message from my other computer. So, but here is the shell that I was trying to prepare. But I'm not sure that I can go through the next phases or it will work. I'm not sure, but I can make it clean. Actually, I have the clean form, but not right here. I will message again, but you just have to tell me that can I go through this form? Then actually I was developing this concept for my current project. Wait. Not here. Okay, I'm actually sharing the main file, a submitted file. Anyway, that's never mind. Can you develop this type of form for our project?
Let me just say that for the Physarum, there is no difference a lot. That's what is the workspace that you want to define for it. It's go for all the foods that you have, but just keep in your mind that maybe you have changed some of the settings.
I really need your help. You know, it's because I don't know how far I can go. Because if you just promise me that it's gonna work or from your experience, then I will work through. I will put my full effort in it because it's just my running project, so it's in my head. I can work very clearly. But you just have to promise me. You just give me a green signal that it will work.
Yeah, we are here to help you.
To go through this process.
Yeah, we are here to help you and help you to have a better output and better destination that you want to go.
Okay, then I will go through. I will go with my group mate. If because you give me green signal, I will go through. I will share this with my group mate now. If they allow, then maybe I will go through it. Then they will help me, or they will also go through it. I don't know. I will share with them because you just think.
Sorry, you want to use this shell instead of your basically that free-form structure, that free-form surface. That and you want to apply that Giri pattern on this, or you want to skip that?
Yes. I want to apply Giri pattern first, so that I can maybe this kind of rectangle might this kind of line might not be there, but I don't know what kind of form Giri will generate, but I will try. I didn't try on this shell yet, but I want to try on this. Then I want to see what happens next if I use Physarum and other ladybug things. I actually spent time ladybug with this. I did the environment solution in other phases in this research, but I didn't apply the GRI and the Physarum yet. So I want you to know that it will work, so that I will go through. I will spend time. If you just
really
promise me that you will help.
Yeah, I really appreciate your design. I really like it actually, because you're inspired by this snail shell, and then you change it to convert it to a very nice form as a small temporary structure, which I really love. In the workflow that we are pursuing is that we need to somehow apply this Giri on the surface. So we cannot promise you that this will work. I would say that just instead of having this these lines that you made from this pure surface, have your pure surface, which is the first one. I don't know if I can annotate or not. The first one, which in the circle. So that one is like the freeform surface. And apply that freeform surface to see if that Gary can basically work on that freeform surface or not. So my suggestion is that first go for that.
I got polysurface.
Let me try to annotate
I got
it.
polysurface.
You got polysurface. Okay. I mean, Behnaz, what do you think? I mean, if he can apply this Gary on this complex surface first, and then we can be sure that, okay, the Gere can be, is flexible enough to work on that surface. And then you can move to the next stage, which is Physarum. Because otherwise it will be, I think you should skip the Gere part and immediately jump to the Physarum to have, for example, a cladding surface on it, or to define the space on it, like the entrance, or some aspect of it.
Just before Behnaz's explanation, I just want to say that I think the bunch of Gere that we have in the clusters and the workflow, you can use it, but for applying those Gere on the surface, I think if you are have a good skill on in Grasshopper, I think maybe you can apply it, and you can use our experience, and if you have any problem in solving this problem. But Behnaz, go for your answer.
Okay, then I will go through to my teammate first. I will share with them, let them see. Then I will also share with you if I got any problem. And thank you for promising to helping me.
Yeah, just test it. It's all about test and error. Just test it to see if it really works and which one. So Behnaz sent, I think, quite a couple of different Gere pattern. So maybe one of them can work. I'm not sure. Behnaz, what do you think? Behnaz is the
to be honest, first of all, this project is marvelous, and you see, we use the Gere as a structural. It's not some wallpaper that it has a meaning, and when this structure stand by itself, why we need that Gere to add to this. And additionally, that Gere we created because it's gonna be playing structural rules. It's gonna be big one. It's in scale. Each Gere is 2.5 meters. So we are not gonna have this marvelous, in curvature we have here. It's gonna we cannot create this kind of form again.
Complex.
And yeah, it's gonna be broken, and it's not very smooth lines, and also this stands on itself, and you have the role of structure already. Why you need that? If I was you, if I was in your shoes, I would use this and add the Physarum on it. Or as Merzad mentioned, we can use Parakeet and growth pattern to add some static feature, or use Gere as a static feature, not structural. But we can use this and analyze it with Karamba, and maybe we can use Karamba for figuring out the number of the lines we have here, and the number of the arches you used in creating this marvelous final form. But I think Gere in that meaning we used it wouldn't be meaningful in this project. But why not going for another another approach? This is unique and quite and can add a meaning of old from biomimicry, and using bio for creating the form old stuff. It's quite marvelous. Good job. And also we were brainstorming and based on the talk we had today, I want to say you can add another meaning to it. For example, maybe this is in a stage for some street performances, and they might need some better acoustic function into this. So you can add a multiple food instead of using karamba and gere. You can add a multiple food for this specific architectural design.
Yeah, thank you, Behnaz, for your
Exactly.
I think, brilliant comments. Yeah, and just I want to say that you can use this form for yourself and have developed and use Physarum for other research objects that you want for what I think is very good suggestion for acoustic foods for it to develop the acoustic performance of this form. But I think what we have here is something that it's limited to 10 by 10 meter square to have a how can I say, different approach with same limitation, with same limitation is what we're gonna, how can I say, focus on it in this workshop. But I'm really, how can I say, suggest you that do it, and I think it's gonna be one of our outputs with another approach with another limitations, because it has something to contribute to this workshop. Thank you for your ideas, concepts.
Okay, thank you for the suggestion. I will go through. I will share, inshallah.
I have one suggestion
Yes,
for you.
yes.
I was seeing your design and I was thinking how we can add if you wanted to go with this, and instead of giving the role of structure to the gere, we can use the other structure, other rules for it and for them. For example, we already have the structure, and I was seeing your design and adding all that leaves, and maybe we can add a care pattern on this and ask it to respond to environment, for example, for creating the shadows, and after that another layer of food, maybe as I mentioned, if this is an if it is a stage for some street performances, and we can use other factors such as acoustic and all that. For that mention, you need to this isn't a story. You need create roles and give each to this person. For example, if we want a Physarum play all the rules by themselves, it's gonna be a monologue. But we need a dialogue between all these rules. So invent another rule for it. As my part, I will make sure to help you as much as I can. But if you can, please, as Ahmed said, please try to create a pavilion that, a shelter pavilion or whatever that goes through the rules. But if as an additional, if you had some additional time and wanted to go through what we speak in what we discussed in this workshop on your work, we can I would definitely help you to go through everything, any possible challenges you will face.
Thank you so much. That means a lot.
Thank you.
Inshallah, I will then put my effort into it for further development.
Inshallah.
I will close
Just
in sharing. Actually, I
yeah,
shared
just
to ma'am, Selda ma'am, the clean photo. Okay, because in my laptop it's very roughly, but I shared clean photo with Selda ma'am. I hope I will share from other computer to here in the Discord clearly, so that I can discuss with my teammate also. Okay, thank you, ma'am. I'm closing. Thank you.
just a minute. Selda, can you share your screen with that PowerPoint that we have biodata flow and force flow integration, the research that we have with Patrice and Crispina?
You mean the Physarum one?
Yeah. I think
just that poster, you mean?
Yeah. One of the ideas and the concept that we have there is just the integration between the force flow and the bio-inspired data. And I think one of the foods that you can give to this Physarum in your case, it's just have some Karamba analysis and then give the force flow. Wait to see. So that's screen.
Can you see my screen now?
Now, yes. You can see that the force flow, we have the force flow from Karamba, and then we give it to the Physarum as a food. So Physarum will go to the points to define some elements for you. I think it's gonna add some value to your form, because it's a form that a bit optimized by the nature, and we can see how it's will be adapts to each other. Yeah, that's just. Thank you, Selda.
Again, I lost the connection maybe.
No, it is okay. Okay, Neda, you have any question?
It's kind of off topic. I had a cafeteria project last year, okay, and I tried to make it like a free form structure and all, but I just couldn't model it at all. I'm not sure if I have its plan or not, but I was interested to know if it can be created by your structure or by that process we're trying to do. I'm not really sharing it as an idea for the team. I'm just curious because I got really interested in free-form structures and stuff like that after I struggled in that project so much. So I'm not sure if I can share it or not.
Yes, sure. Please share,
I don't really have.
Yeah, it will be easier to understand.
Yeah, if you can share.
I only have the plan now. I don't really have the whole presentation of it, so I may share it later too.
Do you have anything to share now?
Only the plan, to be honest.
Okay.
Or even the outline of the plan. I don't really have the plan.
Okay, I think that if the outline is 10 meter and 10 meter square, yeah, it's the same case. Or if you can have some redesign on your plan, it can be adapted to
I
what
think
you have
it's
here.
much more than 10 meters square.
Oh.
It's a big cafeteria, but it's like the structure moves around. So the curvature on it, that it touches the ground, I think less than. It keeps touching the ground. It in its sections or whatever, it has oval shapes. I will try to shade even in the Discord group. I don't mind. It's manual and it's kind of trashy, but I will just share it for my curiousness. But I still don't have it now.
I think Nada, it will be fine, to be honest. The only thing is that maybe it will use more GPU or I don't know CPU from you to run the Physarum. Maybe you can test it, or yeah, I would say start by testing it, and yeah, just don't afraid to test it to see if it works at least with the Karamba and the Giri pattern on that. And then after that, let's see. Maybe we will help you to see, to change the settings. So hopefully it can go to that much yeah, the big area. But yeah, there is a chance that it will crash because the settings are, you know, it is a bit hard to manage the entire Physarum. Yeah.
Oh, okay.
But yeah, just
So,
it really depends on your design and your system, you know, your GPU and stuff.
yeah, okay. So, is there another way to model it other than your own way or stuff like that? Because to be honest, I don't really have an experience much now in programs, but I was really curious about it, to be honest.
I think if you have any idea, you can share with your teammates. Maybe your teammates are gonna help you with it. I think in your group you have Sazat, Behnaz, with a lot of experience. They can help you. Even we can help you. Behnaz
Yes, for
is
sure.
Even.
I will really ask them, to be honest.
Yeah,
but
sure.
even
Just
you
share
can
them.
count on us. Yeah, you can count on us. Just share it to see what you have
on
in
Miro
your
board.
mind.
Okay, for sure.
Yeah. Also,
Yeah.
you know, Sazat, also you can also share it in Miro board, and then we can see, you know, the teammates brainstorming there, and then we can, yeah, come to a solution, come to conclusion.
Should I share the whole presentation of it?
No,
Or
you
just
don't
the
need
plan?
really. If you want to share it, but you don't really need to share it right now. I mean,
to be honest, I don't really mind
feel
sharing
free.
it, but it's kind of wacky, you know, because it was my first year in architecture programs, projects and stuff. So
You're an undergraduate first year or postgraduate?
I'm an undergrad.
Oh,
It's
that's so cool.
we have
Oh,
5
you
years,
have a
and the
long
first
way
one is
to
like.
go.
It's very amazing that you started
Yeah.
from now. My first year of architecture, I didn't I didn't do that
Well,
much. So yeah, just it's amazing. So yeah, I would say just go for it.
The only problem is just I'm very, very behind in everything. I don't really understand, but I'm trying my best.
Yeah, the recordings I believe now are available, all of them. Yeah, yes, Ahmed. So they can. I mean, the recordings are available right now. Yeah, in our channel. Yeah. So you could, yeah, you can just go through them very quickly. And yeah, again, I'm saying that you have time. Don't worry about that. Try your best to observe how much you can, and then yeah, you have time to review everything and put your own ideas in the in our workflow.
Yeah, one of the things that is very important in this platform, Digital Future, is that is about the outputs. That they are really focused on the output that they want from any workshop. I think with this idea that you have, we can have wide range of outputs, and please share the ideas between your teammates, and I think it's gonna be something that's combination from all of your ideas, even from Mirzad with many years of experience, or from Nada that she's from an entry level to this field. Yeah, it's okay. I just want to say that this group, the group number 3, is just Hall of Fame. All of you have good ideas. Yeah, and
thank you so much.
Yeah. If other guys have any idea to share or ask any question, we are here. If not, we can wrap the session.
And don't worry, tomorrow we'll have more time to go through the ideas, one by one.
Yeah, I think tomorrow.
Don't worry about that, because now we passed the half of the workshop, which was the heaviest part of the workshop, and then after this we can have a more communication with groups, and yeah, hopefully.
Yeah, I think tomorrow and Friday, our main task is working on your projects. Even tomorrow, I will not present a lot of things. I think just one part is enough. Before the break, I think it's gonna enough for me on modular design. And then we have 1 hour and a half just for your projects, your ideas, and even you, if you need to speak with your teammates in a break room, I can break your room to speak with each other. Everything is possible. Everything is possible. Just you can came with your ideas, with your concepts, and we will help you to use this workflow and make it possible to use it in this workflow. Yeah, yes, guys, we can answer any question you have. If there isn't anything, we can wrap it up. Thank you for all of you that's to being here today, and I'm really happy to have all of you here because you guys, all of you have amazing ideas and amazing concepts. Just go for it and let everything become more serious in this workshop. Yeah, Selda, Behnaz, if you have anything to add or mention, go for it, and then we can wrap it up.
Not really for today. I think we can, close the session and then continue from tomorrow with more ideas, hopefully.
Thank you for accompanying us, Selda, today, and Behnaz.
I don't have anything to add, but I just want to say thank you, Ahmed and Selda. That was astonishing, and thank you so much, everyone, to joining us today. Hopefully, we will see you tomorrow also.
Thank you. Thank you, guys.
Thank you, Behnaz, for being here today.
See you
Thank
tomorrow.
you, guys. Bye-bye. Have a good night.
Bye-bye.
Thank you.
Thank you.